and welcome to Channels, the Nextflow podcast. I'm Geraldine, lead developer advocate at Seqera, and today I'm joined by my colleague Ben Sherman from the Nextflow team. We're going to talk about the differences and similarities between Nextflow and WDL, the workflow description language. Ben, welcome. You're a longtime contributor to the podcast, but let's have you introduce yourself for our new listeners.
Well, thanks for having me again. Yeah, so Ben Sherman, software engineer at Seqera, one of the main Nextflow developers. In particular, been working a lot on the Nextflow language and sort of thinking through lots of problems in the language and things we can make better. And of course, one of the big comparisons that I've actually spent some time looking at is WDL, another workflow language. So I'm quite excited to get into a lot of the nitty-gritty about these two languages. I've never actually used WDL. I've only read WDL code. So I'm coming at it from that perspective.
Well, you should definitely give it a shot. Yeah, so I used to use WDL as my only workflow language. And so I thought that I'd start by giving everyone a little bit of background on what is WDL, where it comes from, and give a bit of context about why it's a really interesting language to compare when we look at Nextflow itself and where Nextflow is going. So WDL stands for Workflow Description Language. It was developed originally at the Broad Institute, where I used to work, which is why I was working with it on a fairly regular basis. Development started, I think, around 2014-ish, around that time frame. It's kind of the same time frame when a few other workflow languages started being developed at a period where the previously existing solutions were starting to show their weaknesses as the amounts of data people were working with scaled up and people needed to get more reproducibility and so on, more code shareability. And so anyway, in the specific context of the Broad Institute, the Broad has, and if you're not familiar with it, it's a nonprofit research institute that's based in Cambridge, Massachusetts, near Boston. And it does a lot of genomic analysis. And this was around the time where the amount of data production in the Broad's genomics platform was really taking off. And the Broad had, around that time, decided to move its main genome analysis pipeline to the cloud. And as part of that, there was a question of what technologies, what software stack are we going to use to do that? And the teams that were involved kind of did a review of the workflow management solutions that were around at the time. There were at least three that I'm familiar with within the Broad itself. So there was something called Q, which was integrated with the G8K itself. So G8K, the variant calling tool that the Broad had developed, was very rapidly becoming kind of the most widely used genomics toolkit, in human genomics at least. So it had its own kind of co-integrated workflow solution called Q. There was another one called Firehose that had been developed by the cancer group at the Broad, and the genomics platform itself at the time, the genomics platform being like the genome factory side of the Broad, was using something called Zamboni, which the name of the big machines that polish the ice on hockey rinks, which later led to a lot of very amusing internal memes about Zamboni machines in the cloud. As a whole thing. But anyway, that was kind of the selection that existed within the Broad. And they also looked at some contenders outside of the Institute. The main contender at the time would have been CWL, which is a common workflow language. And that was a project that started around the same time coming out of the BOSC CoFest. So BOSC is the Bioinformatics Open Source Conference. And there was a small community effort that was starting out with the goal of developing workflow language that would be portable and reproducible and all that good stuff. And in terms of design objectives, that was very similar to what we were looking for, but the engineering team felt that CWL was too machine-oriented, too engineer-oriented, and they wanted something that would be more user-friendly, that biologists would be comfortable working with. And as far as I'm aware, they were not aware of Nextflow at the time. Nextflow, I think, started in 2013, so it would have been around that same time frame, might not have been big enough at the time. And so based on that selection and looking at a few commercial off-the-shelf solutions, they decided, okay, there's nothing that fits the requirements exactly, so we're going to do what bioinformatics does best, which is write a new one, right? And so they decided to develop a new language that would be a DSL, so domain-specific language that would be designed to be specifically user-friendly, cloud-native, and be reference implementation for the Broad's genomic analysis. And so that's how they came up with WDL, Workflow Description Language, which is a very self-descriptive name, but it's annoying to say WDL, so we just started saying WDL, even though some people pointed out that in British English that can lead to some fun jokes, and that's fine. Anyway, that's just the language. And then in parallel to that, built an engine that was separate and named separately, and that's Cromwell, Workflow Management Engine, which is a little different compared to Nextflow, where Nextflow is both the language and the executor. So in the WDL world, you have WDL, the language, and Cromwell, the engine. So that was developed, and today WDL itself is a community project. So it's an open source project that's run independently by folks who are invested in its development, and it's on version 1.2 of the language. Came out, I want to say, earlier this year, and it's supported by two main engines, Cromwell, which is at the Broad, and that's focused very much on the production use case of high-scale execution. And then there's a second one called Mini WDL at CZI, so the Chan Zuckerberg Initiative, developed by Mike Lin. And that is developed much more on prototyping and development. So it's more the developer use case. So yeah, that's kind of the context of what is WDL. And I will say, so my experience with it has been mainly around supporting the genomics community in using it. At the time it was developed, I was responsible for supporting the genomics community that was using the GATK toolkits. At the time, a lot of people were adopting GATK and wanted to implement GATK pipelines according to the GATK best practices that the Broad recommended. And so when we started being able to share the WDL pipelines, that was actually a very helpful evolution, because prior to that, we'd say, okay, we have pipelines, but the Q ones were very complex because Q is in Scala. So sharing the pipelines didn't really help the community. And we couldn't share the production pipelines because all the Zamboni stuff was extremely complicated. It was just not stuff that we could share. And so moving to this framework where we could give people actual scripts and it was readable and all of that, I think was a big step forward. But there were some limitations, which we might touch on. But it was a big step forward. And the fact that WDL itself was designed to be more user-friendly, I think was very helpful. And as a caveat, I trained as a wet lab microbiologist. I never had a programming class or a coding class or anything like that. I just taught myself Python during my PhD for the needs of my project, which is a very common story for many people in the field, right? And I found it pretty easy to understand and even write workflows myself with WDL, partly because it's intentionally very constrained in what you can do with it, which is great for readability. But then on the other side, for developers, the common complaint was that it was too limiting. And that's something we'll be talking about in a moment. I guess the one additional thing I would say, it was designed with the dream that I could write my pipeline and then share it with anyone in the world, and they could run it on whatever infrastructure they had, whether they were running on-prem HPC or on one of the major clouds. It would just work the same way anywhere. In practice, it didn't quite work out that way. Those specific teams were working exclusively on Google Cloud at the time, and so while the intent was there to support any backend, in practice, it didn't quite work as seamlessly as we had hoped. And so there were some important limitations there. So when I moved to Seqera last year, I learned Nextflow, which was a big, interesting jump, I would say. Coming from WDL and moving to Nextflow, I would say was interesting in two ways. One, there were tons of code examples and training materials and all of that for Nextflow, a lot more than for WDL, honestly, partly because it's a better resource. There's actual people whose job it is to make training materials and give training in Nextflow. And there's a bigger community, so there's just more pipeline examples and code that other people have written. So that's very helpful. But then there were some interesting learning curves to the process, the experience of learning Nextflow. And I would say the most challenging part for me was channels. I think that's the experience for a lot of people. Channels are the way that Nextflow shuttles data from one task to another. And I should say on the terminology, just to define this up front, between task and process. WDL refers to like a job as a task. If you have a command line that you need to run one of the steps in your pipeline, that's a task. In Nextflow, that's a process. Your workflow is a series of, or a graph of tasks or processes that you need to execute and chain together. You have task A produces an output, and that's going to be the input to task B. The way you express it in WDL is pretty straightforward. It'll be a file or a set of files or something like that. And then you pass the file to task B, and that's pretty much it. It's fairly straightforward. In Nextflow, you use a channel, and the channel can be a single value or a single file, but it can also be a list of files or things like that. And task B is going to consume the elements in the channel that are output by task A. It's very similar in principle, but the way it's expressed, I think, is fairly challenging. And Ben, I should let you respond at this point.
Yeah, I would say that under the hood, like in terms of the runtime, Nextflow and WDL have, I think they have basically the same concept of a task. And the main difference lies in the language and how the user expresses what they want. So I think in WDL, you're invoking every task explicitly on concrete inputs. Whereas with Nextflow, you're sort of stepping back and you're setting up a pipeline. The process is sort of like a prototype that will generate potentially many tasks in the same way that a channel is sort of a prototype that may contain many different inputs. And so you're hooking up this process to a channel and saying, you know, for every value that comes down the pipe, execute a new task. And so that can be sort of a powerful way to set up a parallel pipeline without a lot of extra code. But I do agree with, I had a much similar experience as you when I learned Nextflow many years ago, was sort of grokking that translation in your head of like, you set up these channels and processes, and that's going to translate to these tasks with these specific inputs. And that's probably one of the things that contributes to this idea, to this common idea that many people have expressed, that Nextflow has a sharp learning curve, but once you get it, you know, like it's worth it. And that's what everybody has been saying so far. But I agree, it would be nice to find some way to make that, just make that clear to the user, like when you're reading code, to make it more obvious. But we can
yeah. But it does come down, I think the way you express it is more clear. I do think it comes down to how explicitly versus implicitly things are expressed in the code. Like it's really, just to give an example, a more concrete example, let's say I'm aligning some sequence data, and for each sample, I have a file of sequencing reads, right? In WDL, you would explicitly say, this task takes in one sample's data, and it aligns the data and outputs the mapped data in a BAM file. Okay. And then if I want to parallelize that, if I want to run that as a batch job over many sample files, I will use what's called a scatter function. And I say scatter for each file in a list of files, I'm going to apply this task. And so it's very easy for learners because it's basically like a for loop, even though it's functionally, it's going to scatter things, but everybody understands immediately, like, oh yeah, for each file in my thing, I'm going to apply this. And I take the output of that and I pass it on to the next bit. At the end of the day, Nextflow is doing the same thing, but that scatter is built into the channel itself. Nextflow understands that that's what you want to do with it, with your list of elements, without you having to say explicitly. And I think it is really neat that you can be more economical in how you express it. But on first approach, it's like, wait, but how do I parallelize this stuff? I'm like, oh no, Nextflow is just going to parallelize it.
Already doing it. It just happens.
It's like behind the scene magic, which is nice, but it's like, oh, okay. Now I have to reconfigure how I think, like at what level I need to tell my code what it needs to do.
Yeah, the processes and channels really seems to be what sets Nextflow apart from not only WDL, but actually most workflow managers. I've spent some time because, there's hundreds of these workflow managers out there, right, across many domains. And I've studied a lot of them trying to, look for good ideas to take in. And that always seemed to be the thing that tripped me up, where I would see a good idea in another language like WDL, and I couldn't quite figure out how to translate it into Nextflow because, well, Nextflow has these channels and none of these other systems have channels. And how do I reconcile all of that? I think what I realized was that, to your point about the scatter, the equivalent concept in Nextflow is really the map operator, or also the flat map operator, depending on how you structure it, because that essentially is a way for you to say, for each value in a channel, perform this operation. And in fact, what's going on when you invoke a process with a channel is you are implicitly saying, for each value in this channel, invoke this process, like invoke a task from this process. So every process call that you have is actually, there's sort of a map operator like hiding inside of it. Nextflow puts it in there for you. And so what I realized was, well, maybe one way we could make this more explicit is, what if instead of passing a channel directly into a process, you explicitly say that dot map, you say, your input channel dot map, and inside those curly braces of the map operator, you call the process. And what happens then is that in that map closure is the term for it, you're able to access the individual value that represents like each value in the channel, right? And so now, instead of calling the process on a whole channel, you're able to call it in the map operator on an individual value in the channel and control exactly how it's called. And then you're able to see in the code, okay, this is exactly the values that are being executed, right? This is not real, right? What I'm talking about, just so everybody's clear, I'm sort of sketching out a potential idea of how we could actually make Nextflow more explicit and sort of take that nice aspect from WDL and many other managers. This is something I'm going to be experimenting with probably over the next year, is trying out this new syntax. Obviously, I'm curious if people have opinions on this. I'm happy to take feedback. I've shared this internally with a few people already, and people seem to be on board. But this is one way. The point in saying all this was that was sort of the key realization that I had about how to understand how a language like WDL sort of equates to something in Nextflow. And I think especially Nextflow DSL2, which introduced this pipe operator, which was sort of a syntax sugar, a shorthand for when you have, a chain of channels and operators and processes, instead of doing, calling each process on a new line, you could just, if your processes were sort of structured the right way, where every process had one channel coming in and one channel going out, you could just say, okay, take this channel, pipe it into the process A, and then pipe that into process B, and so on and so forth. And, I think Paulo and I really like that because it sort of evoked the same ideas like bash, right? Where you can pipe bash commands into each other. And that's really nice when you have, say, like one input file, and then you pipe it through a command that, maybe does some filtering, and then another command that does some transformation, and just so on and so forth. And you get this really nice sort of pipeline. And each step in the pipeline is doing this very simple, easy to understand thing, right? But then you compose them together. That is the Unix, that is the philosophy of like the Linux operating system, is have all these little simple tools and just combine them together with the pipe. And in Nextflow, we were sort of able to capture that idea. Of course, it's a bit brittle, because the moment that you have a process with two input channels, well, now you can't do it. Or if they don't quite match up, or if you have these extra arguments you have to throw in, like it doesn't quite work. That is also something that I would like to improve upon. But that's also just wanted to expound a bit on, I guess why Nextflow has sort of optimized around this very, basically a shorthand, of processes and channels.
I mean, I like the idea of for things that are straightforward, one in, one out. I really like the idea of being able to chain them together in a way that's very compact and very readable too, because then it's very easy. You don't have to wade through a bunch of lines and you're like, oh yeah, you're doing A, B, and C in a row on the same set of data in the same way. I think that's very readable, and I think it's okay if you can only do that for the bits that are straightforward like that. And whenever you have more complex, more complex plumbing, then you have to write it out a bit more explicitly. I think that's fairly reasonable. I did want to mention on that note, one of the things that I was very impressed by when I started learning Nextflow, once I'd wrapped my head around the channels enough to understand also the channel operators, right? Because you mentioned operators a little bit already, but there's a whole set of different operators that allow you to do some pretty cool things, including filter out of the packets of data that are coming through this channel, be able to sort them into separate piles and process the piles differently. And I like the example of if you're doing cancer genome analysis and you have tumor normal pairs. And so some of your samples are from like tumor biopsies, and some of your samples are the reference normal, so it's a blood sample or something like that. And in your analysis pipeline, you want to do some parts, especially early on, there are some processing steps that you want to do separately for the tumor and the normal. And then you want to join them back all together. It's really neat if you can dump everything in one channel in the beginning and then have an operator that sorts them into separate branches of the workflow. Mm-hmm. Do the separate processing, bring them back together, and it's a very nice compact way of expressing all of that, and that's really neat. And that's, just to be clear for everyone, that's not forward looking, that exists already. And I think that's one of the really neat parts that is a big plus. It does mean that there's more to learn compared to something like Whittle that is intentionally constrained, where there's not a lot of things that are part of the DSL, where it's just is very focused on plumbing at the workflow level, but it doesn't let you put a lot of the biological logic, I want to say. All of that you have to do it kind of upfront yourself. Whereas here, as part of the workflow, you can really go and make decisions about what happens to the data based on what's in the data itself. And also, correct me if I'm wrong, but I think you can even, like, if you have some samples coming in, you can do some QC, right? Some quality control. And then you can read the results of the QC, and you can decide, well, that sample isn't meeting the QC metrics, so I'm going to fail that one out and stop processing it. This one is intermediate, so I'm going to run something remedial on it to see if I can rescue it. And this one is good enough, so I'm just going to go straight to the rest of the analysis. And you can do that at runtime, which you can't do in Whittle. In Whittle, you cannot peek into the results and decide on the next step like mid.
Oh, interesting.
You would have to do a workflow that runs, and then you have something that looks, and then you would run another workflow based on the results. But you wouldn't be able to just send the data to different pipes based on what's in the results, which is super powerful.
Interesting. Yeah, when I was looking into Whittle and trying to find parallels with Nextflow, it seems like the closest thing Whittle has to the channel operators is, Whittle basically has a fixed standard library, right? So that includes a bunch of utility methods for, strings and arrays and different kinds of utility methods. And a lot of the standard library functions I saw in there, particularly ones that were manipulating arrays, seem to be very similar to operators. Just instead of manipulating it, you can think of a channel as a sort of an array, right? It's a collection. A lot of the same channel operations we have were also supported in there. I imagine you could probably re-implement a lot of the same data flow logic from Nextflow in Whittle, but it might look a lot more like traditional sort of imperative code, doing a lot of if statements and scatters and things of that sort. And I think that's the operators is definitely one of the things that makes Nextflow stand out and makes it seem a lot more powerful than many other managers. I think because you can do a lot more with a lot less code.
Mm-hmm. Yeah.
And really, the channel operators in Nextflow, anybody who's done functional programming or reactive programming, which may not be, I don't know how many bioinformatics people get into this space, but software engineers, functional programming is sort of a black hole where once a coder discovers it, they get sucked in, and then you want to make everything, you want to do everything functional. And it's Nextflow operators are basically just that. It's a sort of a functional reactive programming, and it's really it's nothing new. These concepts like channels and map and filter and reduce and flat map, all these concepts have been around for decades in other languages. In fact, I think Scala probably has these as well. You mentioned Scala. And we basically just copied that and incorporated it into the language. And so you're able to do a lot of interesting things and a lot of this sort of boilerplate, like plumbing logic that people always have to deal with. You're able to think of it in almost a visual kind of way where you, like you were saying, you could imagine, you can visualize in your head like the input files coming in, and then you're doing this little analysis over here, and then you bring them back together and to do like the quality analysis, like you said, and then based on that you're branching off into all these different routes, right? You can sort of see that in your head just from looking at the code, and that's something that is very strong.
You're talking about the visual aspect and seeing it in your head, and when you're describing that, I'm visualizing flow cytometry diagrams. The idea is that you tag, I know it's a very wet lab thing, you tag a bunch of cells with some fluorescent markers or whatever, and then you put them through a microfluidic device, and then you have a laser that detects which tag they have, and you send them in different channels depending like literal channels, right? And then you do different things and you count the cells and stuff like that. And I tend to think of the workflows like that, where the cells are the little packets of data and they're kind of flowing through the microfluidic device. That's kind of, sorry.
Well, no, it's funny because I do the same thing. I think of workflows as just electric circuits or like computing logic, like hardware circuits, because that's my background, right? So many backgrounds have this, where there are these places in the domain where you use these flow graphs to represent what is going on, because there's so many things just in the world that are just some sort of flow graph, right? Whether you're talking about like a biological pathway or an electrical pathway. So it's funny how everybody will look at these Nextflow pipelines and sort of project their own sort of domain understandings. But it's great because they're all valid analogies. They all work very well, and it sort of speaks to why the sort of data flow programming model is very powerful. One thing I will say is that, and sometimes I think it's a little bit too powerful, where it allows people to, get into some really complex implementations, or to over-engineer things or make things overly complicated to where it becomes hard to read. Sometimes that's just the user's own, lack of experience. A lot of times what I found, I think that there's actually gaps in the Nextflow language that sort of cause people to reach for these more complicated data flow solutions. I think by my count, there's something around like maybe 50 operators in Nextflow. And, in my sort of analysis of the Nextflow language and thinking about different ways to design the language, I think we could probably cut that library in half in terms of how many operators that people actually need. Many operators could just be regular standard library functions. So I guess you're not really get rid of them, but just sort of moving them into a different part of the language. Many of them exist because of shortcomings of the language. And if you address those shortcomings, then you wouldn't need a lot of these operators. But to your point, especially, things like the join operator, the branch or the filter operator for splitting off channels into multiple routes and bringing them back together. That's a very common pattern you see. And honestly, map, filter, maybe collect, and then to your like join. Those are probably the handful, sort of the handful of the most commonly used operators. You can do just about anything you need with just those operators.
Yeah, honestly, it's one of the things where it's about finding the right point of balance, I think, between the amount of options that are available to you and the additional complexity that each new option adds. And I think WDL tried really hard to keep the complexity as low as possible, and probably went a little too far in that direction. And subsequent releases have added more flexibility, added more options. Each time there's a lot of debates by the kind of the core group on what's, do we really need this additional function that somebody is suggesting be added to the language? Some of the things like the tumor normal example I gave, you could approximate a lot of that in WDL, but the syntax is awkward, the way you have to express, because then you have to be if, property is something or other. But anytime you have an if statement in WDL, you have this complex logic that you have to add for the cases where the if is not satisfied. And you have to be able to say, oh, what output am I going to have to grab depending on the results? And you have the select first syntax, which is, that's one of the things that confuses people a lot is dealing with those conditionals in WDL. It's interesting. I feel like Nextflow has moved the needle significantly more on the side of let's give people a ton of power and a ton of flexibility. I like what you say about pulling back some of that to make it a little more like wherever it's compensating for a shortcoming of the language, let's make sure that the language itself is really robust and that there's a good solution for doing the thing. Like making sure that whatever solution is used doesn't lead to excessive complexity or, where it's too much of a gray area and people end up tying up their own feet. I'm not using the right phrase, but you know what I mean. When you give people a little too much rope and they end up tripping on it. I think finding the right points to enable power users, but making sure that people who are maybe less savvy with the language don't end up shooting themselves in the foot in the process of trying to use these things.
Yeah, I mean, I think Nextflow's flexibility is a huge reason why it's been so successful, is because it has allowed people to, handle those more advanced use cases where, that no longer becomes a blocker, where, and then the downside is that sometimes, people like you said, they end up shooting themselves in the foot. But you can recover from that. And especially, when you have lots of documentation, like you were saying, we have tons of code examples. Because honestly, that's the best way that we found to teach people is just show them by example. Here's how you do X, Y, or Z. And then now that it's really becoming an industry standard, and we've got things like the NF core pipelines and just all of these really great examples of the best sort of Nextflow pipelines and really pushing it to its limits. I can start to take a high level view and see, what are the most common use cases. Like you were saying, where is the library stuff compensating for language shortfalls? And, it's honestly taken me probably 2 or 3 years to really think. I mean, some of these problems I've been thinking about since I joined Seqera almost 3 years ago. And that's really how long it's taken me to just sort of absorb all these patterns and see what can be done. So it's been a good process. But also, to what you were saying about WDL, I think this was maybe another topic we could get into about WDL. I really appreciated, of course, I haven't been around this space as long as WDL has, but from what I can see about the WDL spec, I really appreciated the design choice to actually go with the DSL, like you were saying, rather than just, relying on a full programming language like you were talking about with Scala, or like CWL, which I believe is basically just YAML, right? And then you have the ability to do some JavaScript maybe. But actually designing a language from the ground up to be, sort of as productive for the domain user as possible with the least amount of complexity. I think that was a really bold choice and really, yielded a lot of good benefits. There's a lot of good points of inspiration that I've gotten from WDL. And I think one of those points is the fact that it has static types. And so you can specify, you can be very explicit about things being numbers and strings and files even, and then also, collections, and then also these record types where or I guess you can WDL their structs, where you can define, a sort of a compound type that has these members, and then you can pass that thing around as a single object. This is something where Nextflow's lack of static types and compound types has increasingly become a pain point for a lot of people, especially as other languages start to add this, even things like Python with data classes, people start to ask like, hey, why can't I have like a record type? And you actually can have a sort of a record type in Nextflow using some groovy magic, but it doesn't really work in all the ways that it should. Mainly process inputs and outputs don't really work with that. So even more data flow boilerplate logic, right, that people end up adding to make this stuff work. This is something that I would really like to add into Nextflow, hopefully within the next year, if not the next 2 years, is a way to sort of formally specify the types of everything, mainly inputs and outputs, say of like processes and workflows. Once you have those, you can sort of infer everything else, but crucially being able to define custom record type. And then now, instead of having just like a tuple, which is typically what people will do when they want to sort of group stuff together. And then now you have to remember like, well, which element was this? With the meta map is element 0, and then this file is element 1 or 2 or whatever, and have to remember that in your head. You just have this record type where maybe you have two members like .meta and then .reads or something, say for like a sample record. And then now you can just say sample.meta instead of sample, index 0 or whatever. And I think that alone would be a huge quality of life improvement.
I like that a lot. And, another thing that actually kind of bit me recently, I was working on improving some tutorials, and I was reminded again, I was, showing, I have a channel with a single thing, and now, I have my BAM files, but now I want to have my index files travel with the BAM file. So I put them in a tuple so they stay together. And then I added something else to the tuple. And I was reminded that all of that has to be positional. Everything has to be in the right order, and I have to be accessing things in the right order. And when I'm calling my process, I have to pass in my inputs in the right order. And it was like, what I missed from WDL is WDL is not positional at all. You just you identify specifically. Like my call requires an input BAM and an index file and some parameter, whatever. And then I assign them specifically. I pass them. It doesn't have to be in the right order. If I add one later, because I'm adding it by name, I don't have to worry about where it is in the row, which number it is. If you can do something about that, that'd be fantastic.
Yeah, let's just say we've got some plans in the works, because I know exactly what you're talking about. I felt the same frustrations in the past. And especially, processes in particular, you have these input-output declarations. And, WDL tasks and processes actually are pretty similar to each other. There's sort of a parallel with everything there. But especially there, process inputs and outputs, they sort of have like a custom internal type system, like just all on their own. And it's mainly more about, controlling how files get staged in and out of the task than anything else. But especially if we could replace that with basically exactly what WDL does, I think, is just you just have every input is just name and then type, name and type all the way down. And then just being able to access those exactly how you would throughout the workflow code. I'd really like to do that. So yeah, we're going to do it. Now, one thing I wanted to bring up around types in WDL this was something I found interesting in 1.2 was that I think there was some changes in 1.2, but the broader idea was when it comes to structs in WDL, you have the ability to cast from one struct to another if they're basically if their definitions are exactly the same. WDL can basically treat them as if they were the same. And I thought this was very interesting because it sounds like having that feature created a lot of weird edge cases that in WDL 1.2, I think they tried to restrict a little bit. I don't know how familiar you are with this aspect, but I think basically what happened originally was there were all of these sort of extra rules around how to determine whether two types can be cast from one to the other. But in WDL 1.1, basically a lot of these rules were optional. So like the runtime was allowed to sort of, forego these rules. And then WDL 1.2 basically made that more strict. We're like, no, actually, all these rules need to be implemented consistently. I can sort of see the history of how that would have happened because it's one of those things where like being able to cast from one type to another is maybe a nice convenience, but then it opens up all these sort of complexities. And you have to think about, okay, what exactly, and then, 1.2, you can kind of tell they said like, okay, this is getting to be.
Let's pull this back a bit.
Let's rein it in a little bit. And so that was I think that was a valuable lesson for me as I'm looking into the type system now, is that, well, maybe it's better if we don't have all of that. And, if you really need to cast from one type or another, then maybe you just need to write it out and just do the annoying thing. So that was an interesting tidbit for me as like a language designer. Maybe most people will just find that stuff very boring and minutia, but I thought that was very interesting.
Oh, I think it's important. And I would say you're right that it's fairly typical for a language that started very buttoned up and has realized that it's hit some, people have hit certain limitations and then tried to move towards more flexibility. But then, once you roll it out and people use it in the wild, you run into some cases you hadn't thought of. And then you have to, as you say, rein it in a little bit. I think it's pretty normal and fairly typical thing for the evolution of a language like this.
It is.
So it's really interesting to look at the evolution. I would say one kind of parallel in terms of, I wouldn't call it a drunken walk, but it's definitely a bit of a trial and error process, is how WDL handles the configuration stuff in terms of the hardware configurations of what processes require, what a task requires. Let's say you have a tool that requires GPU or something like that. That's where the portability elements come into play, where you're considering it's not just code in a vacuum, but it actually has to run on hardware somewhere. And you have to be able to specify certain hardware requirements or preferences. And WDL started out with this runtime block concept where you'd be able to say, request certain machine types or specify a container, stuff like that. Things that in Nextflow you'd put in the config files, right? And I think you saw in 1.2, they changed from having runtime as a general grab bag where you would put just a whole bunch of keywords, and some of those keywords are recognized by Azure or AWS or Google Cloud or whatever. But then if you want to request the same kind of machine type and have that work on all three major clouds, you'd have to make sure that you're giving all the possible options depending on the platform it's going to run on. It gets a bit messy. And that has changed to having, there's requirements and then there's hints. And the concept of requirements is I need to have GPUs available. However you're going to call it, I need to have GPUs available. And then hints is if you have Intel processors, I'd like to have this architecture or whatever, if available. So it's really interesting to me to see how managing the heterogeneity of the possible hardware that things are going to run is evolving in the language, because that is one of the things that makes portability potentially complicated.
Yeah, I remember encountering this as well when I was reading over everything. So reading about the requirements and hints, which are very analogous to process directives in Nextflow. Mm-hmm. But you can sort of see the consequences of having WDL as sort of a language abstract from any particular runtime versus Nextflow that's tied to a particular runtime. It kind of makes sense why WDL evolved the way it did with this runtime section of okay, you can just sort of throw in whatever hints you want in there, and then whatever runtimes know about those things will pick it up, which is a nice and simple solution on paper. But then maybe in practice you find that, well, it is actually kind of tedious to go and figure out this runtime implements these options and this one the other one and so on. Whereas in Nextflow you basically have a standard set of directives which would encompass both requirements and hints, and basically whenever somebody implements a new backend for Nextflow, a new executor, that executor is expected to pick from those directives. And so you don't have to implement every directive, but if you are going to implement some concept, it's best to sort of grab onto a directive if that makes sense. And so then from the user perspective, if I use the CPU's directive or memory, or we have accelerator instead of GPU, those directives, as long as you know that your underlying platform, supports those, then they will work. And that's pretty reliable. And I think that certainly contributed to this portability idea. Was certainly one of the strong points for Nextflow as well. Certainly one of the things that drew me in was when I realized, wait, I write this one pipeline script and then I can run it on my laptop, on my university cluster, in the cloud. And it's all basically the same code, and it's just a different config profile. Yeah. And that was really powerful. And that's not necessarily something that's unique to Nextflow. I think at this point, there are many workflow managers that have this same sort of capabilities. But a lot of the differences, I think, lie in just the level and quality of support. Yeah. So, I would argue that Nextflow probably has a much wider and deeper support of many different cloud executors and HPC platforms, just because, they've been implemented for a long time. They've been battle tested. People take pipelines and they run them in all sorts of crazy environments, and they find all the weird edge cases, and then we patch them sooner or later. And then over time, that makes Nextflow a lot more stable. Whereas I think a lot of the other workflow managers have good support for maybe one cloud or the other. Like maybe one's really good at AWS and there's another one that's really good at Google Cloud. But having, all clouds, all HPC systems seems to be more of a rarity.
Yeah, I think it's something that aspirationally everybody tries to have, but in my experience, I would say so far, I think Nextflow has done the best job of. And I've been especially impressed by how well it manages kind of the hybrid situation of HPC and cloud, because I feel like those that have been cloud native, like Whittle was cloud native from the start, and the HPC back compatibility was more of an afterthought. And that has been kind of rocky, and local cores have had to just figure out how to deal with it themselves. Whereas on the Nextflow side, the breadth of the community also, I think, has helped. And the fact that like the NF core has that section where you can share institutional config files. Like if you're at any one of those institutions, you can just grab that config file and it'll just work, because it really helps manage. And you have enough, you hear stories too of people who have a hybrid setup and who will do a bunch of stuff on HPC and then they'll burst the cloud. And it's, again, using the same workflow code, and it's just the config files that change. Like that's what it's supposed to be. That's the dream. So
yeah, that's one of, I think, the primary examples of something that's not super complicated engineering wise, but just it's one of those things that just where the rubber meets the road, and for users it's just an incredibly powerful feature. It was funny because I was proposing some changes to the config syntax for Nextflow, and I was going over them with Phil. And Phil started freaking out because, like, wait, I think this is going to break the institutional configs. He was like, no, we can't touch those. That's the holy grail. And people love these. And so, of course, we found a way to resolve those. But I found that very interesting, just how much of a hub that is. And yeah, as far as like HPC and cloud is concerned, Nextflow was actually, I think, HPC first, really. It was really designed for the HPC systems. And it happened to be easily extensible into the cloud, I think, because of how all the interfaces were set up, this sort of executor concept in Nextflow.
And also, I think the containerization of the processes, the fact that the processes are very isolated from everything else. That seems
the way that like every task runs in its own directory, all the files are staged into it, and then, even like actual software containers is just another directive you can tack on, because all that stuff already existed. It was very easy to, translate that into the cloud. Although I will say that there were a lot of sort of performance bottlenecks that I think were introduced, where things like, in HPC world, you don't have to worry about spinning up and tearing down VMs, right? So then now you take that same model to the cloud, and now every single job you submit is spinning up a new VM and then tearing it down at the end. It creates a lot of overhead, and we're finding ways to amortize that and eliminate it as much as possible. And then also like having your work directory, instead of it being just a file system that all the HPC nodes have access to, now you're using S3 or some other object storage, and you're having to copy data back and forth between the VMs and S3. Of course, Fusion was developed as a primary solution to that, trying to make S3 as much like a regular file system as possible. But once you sort of recover those inefficiencies, you can have much the same experience as you would on HPC. So I think it's worked out fairly well. There's still some gaps, especially with Google and Azure. There's some small things that we're trying to close, but it's really just a matter of time, right? As more users use those clouds and they push the limits and we address those gaps and fix all the bugs and stuff like that. I mean, it's really coming a long way.
And I would say that that's a perfect final word. It's all come a long way, and it's going to continue to evolve. Thank you for your hard work on that, Ben, continuing to look ahead and getting inspiration to keep improving it for our user community. I think that's fantastic.
Yeah, for anyone who's using Whittle and who likes it, I would just say, just stay tuned. Keep an eye out for what's coming in the next year or two, I think you'll like what you'll see out of Nextflow.
Nextflow try, yeah. All right. Well, thank you very much, Ben. It was great talking to you today. Thank you, everyone, and we'll see you next time.
Bye, everybody.